Hello, it is the 2nd of December, and that means it's Advent of Code Day 2. Let's get that downloading. It's still called util. And let's have a look at the puzzle. Okay, so we need to figure out how to pilot the submarine. It has a series of commands, forward 1, down 2, or up 1. Only of those three, okay. We have a horizontal position and a depth. We have the opposite result of what you might expect. Okay, down and up have the opposite result, but the submarine seems to already have a planned course. Your puzzle input, you should probably figure out where it's going. So forward 5 adds 5. Down 5 adds 5 to your depth, resulting in a value of 5. Up 5, okay, yeah. So we're measuring depth rather than vertical height, sure. You have a potential position of 15 and 10, multiply these together, produces 150. Okay, cool. It's a simple, like, sum and modify puzzle. And we have our puzzle input nicely configured here. Let's go and sort this out. So I'll start by specifying our test case. It's this input here. And we are going to assert task pass task 1. Test is, what do they say? They say 150. Nice. Okay, we'll need to pass our input. We're going to need to use nom character bytes complete tag. We are going to need character complete line ending. We are going to need branch alt. We are going to need combinator map. We're going to need... We're not going to need combinator value. I think that should be what we need, but let's see. So for our input format, we are going to have instructions, and these are going to each be an instruction. An instruction has got a kind, which is an instruction kind, and it has a magnitude, which is a I32 for the sake of convenience, and then a instruction kind can either be forward, up, or down. Right? Yep. Okay. So now let's write our parser. So first things first, we need to say let forward is map. Or I guess forward just needs to recognize tag forward. Up is tag up, and down is tag down. Then instruct. Oh, we also need I32, obviously. Then instruction kind is alt forward up down. It will match one of those. Okay, and let's map these into their instruction. So this gets mapped into, these can actually take value. These can use the value one. So we'll bring in combinator value as well. So we have a value of instruction kind forward for the tag forward. We have a value of instruction kind up for the tag up, and we have a value of instruction kind down for the tag down. Okay, and then we need to do a separated pair as well. Sequence. Now value, it's actually not going to like because our instruction kind isn't cloned, but our instruction kind can actually be copy, so that's fine. That's very cheap. Okay, so now we need to say let instruction equal separated pair, and the pair we also need just car from in here. it's just called recognizes one character. And our separated pair is going to be an instruction kind, a car of a space, and then an I32. There's our instruction. Instructions is going to okay. Now let's do this in places. So then let's map that into, and we've got a kind and a magnitude. Our instruction of kind and magnitude. Kind base. Yep, that all is actually fine. And then we just need to let instructions is equal to, and this should actually be a vec of instruction. Instruction I can spell. Separated list one. And so let's bring that in. Multi separated list. Line ending and instruction. Okay, and now pass is going to map instructions, and then pass input instructions, pass input, and that is going to give us our parser for today. In theory, car needs to actually only be a single character. Cool, so now we can check that that works. Let's just throw debug onto these. And okay, and then we can just say debug input. And then if we run this, we should get a nice look at the parsed form of our puzzle input. No? Debug is a macro. I need to put an exclamation mark after it. Yep, that all looks to be reasonable to me. Okay. So for our first puzzle, we need to okay. So we need to do input.instructions.iter.fold. Now we're folding over an x and a y value that both, I guess, start at 0. Yep. And our fold operation needs to look at the kind of the item. If it is forward, then we return now our app is best stated as xy, then we return x plus item.magnitude y. If we are going up, then we return x and y minus item.magnitude because our depth would decrease. And here we return xy plus item.magnitude because our depth will increase. Are you expecting a unit type? Because I'm saying that this returns a unit type. Okay, that's fine. And then we're going to we need to say slightly more procedurally rather than all in one place. Let forward depth equal this. Forward times depth, and that is an I32. Okay, now if we run our test should hopefully pass. And it does. Okay, so now let's run our code and get our first result. Big number, but correct big number. Okay, and now for part 2. Based on your calculations, the planned course doesn't seem to make any sense. You find the submarine manual and discover the process is actually slightly more complicated. In addition to horizontal position and depth, you'll need to track a third value, aim, which also starts at 0. The commands also mean something entirely different than you first thought. Down X increases your aim by X units, up X decreases your aim by X units. Forward increases your horizontal position by X units, and it increases your depth by your aim multiplied by X units. Okay, that's fine. The way we've written this, that should be pretty easy to translate. So in here, we need 3 values. We're gonna let's actually give them better names here. So this here is forward, this one here is depth, and in here we're gonna need forward, we're gonna need depth, and we're gonna need aim. Also starts at 0. Again, for the video. Okay, and now for this, down increases your aim by X units, but leaves the others the same. Okay. Up decreases your aim, and forward increases your horizontal position by X units, and then it increases your depth by your aim multiplied by X magnitude. And then in here, we no longer just have forward depth, we also have forward depth and aim, but I'm assuming we only need to multiply together your forward and your depth. Yeah, okay, so forward times by depth should give us our solution. If I go ahead and say that this function returns an I32. Okay, after following all these instructions, this should produce 900. Okay, let's check that it does. 900 on task 2. Run test. Passed. Okay, let's have a look at our actual output. Big number. And task done. Alright, that was nice and fun.